All right. Today we are going to take a look at triangles. Specifically, we are going to be classifying triangles and then finding missing angle measurements within triangles. We learned that there are different kinds of angles: acute angles, right angles, obtuse angles, and straight angles. Well, since a triangle can't be formed from a straight angle, we're not going to worry about those today. But we are going to look at triangles that are formed from acute angles, right angles, and obtuse angles. Take a look at these on page 556. An acute triangle has all acute angles. So every angle within the triangle is an acute angle, meaning there's no other kind of angle in it. A right triangle has one right angle in it. And then an obtuse triangle has one obtuse angle in it. So if I were looking to determine what kind of triangle I was looking at based on its angles, I wouldn't look to find an acute triangle. Because guess what? Here's an acute angle in this right triangle. Here's an acute angle in this right triangle. Here's an acute angle in this obtuse angle or triangle. And here's an acute angle in this obtuse triangle. So every single triangle has acute angles in it. No, I don't want to look for the acute triangle at all. By process of elimination, I will find an acute triangle if I don't have an obtuse angle and I don't have a right angle. So those are the two angles I'm looking for. If I have a right angle, I have a right triangle. If I have an obtuse angle, I have an obtuse triangle. And if I don't have either, then and only then do I have an acute triangle. Take a look at the three triangles below that. They're called a scalene triangle, an isosceles triangle, and an equilateral triangle. Well, let's start with the easiest one. An equilateral triangle, even though it doesn't look that way on your screen, maybe right now, is a triangle that has three equal sides. So this triangle is supposed to have three equal size sides. So it would be an equilateral triangle. I put those little hash marks on the sides to show that they are all the same. Let's look to its left. This is called an isosceles triangle. An isosceles triangle has two sides that are equal. So these two sides coming from the bottom going up to the top are equal in size. And then the one along the bottom is a different size. So isosceles triangles have two congruent sides. And if you look one more to the left, then you see a scalene triangle. Scalene triangles have no equal size sides. And if you notice, this triangle kind of leans to the left. Well, a scalene triangle, no matter how you turn it, is going to lean one direction as you look from the bottom to the top. So scalene, that's how I remember that it is a scalene triangle, because it leans. Isosceles triangles, two equal sides, and an equilateral triangle, three equal sides. A triangle is a figure with three sides and three angles. The symbol triangle means triangle. Every triangle has at least two acute angles. So one way you can classify a triangle is using the third angle. And that's what I was talking about before. If it has an obtuse angle, it is an obtuse triangle. If it has a right angle, it is a right triangle. And then another way to identify the triangles is by their sides. Sides with the same length are congruent segments. Congruent meaning same size, same shape. So an isosceles triangle has two congruent sides, and an equilateral triangle has three congruent sides.
So let's take a look at example number 1. It says, draw a triangle with one obtuse angle and no congruent sides. Then classify the triangle. Draw an obtuse angle. The two segments of the angle should have different lengths. So since we want no congruent sides, which is what it says right here, we should make sure that when we draw this obtuse angle, that we do one short side and then one long side. That way they're different size sides. Then when I go and I connect the two segments, which is what it says over here, to connect the two segments, I will end up with a triangle, but all three sides will be of different lengths. That is because the side opposite the largest angle will be the biggest size side. So again, you draw a short side and a long side with an obtuse angle, an angle greater than 90 degrees, and then connect the two sides. If you haven't done that, go ahead and try that for example number 1. Then I want you to come down here and I want you to do letter A. It says, draw a triangle that satisfies the set of conditions below, then classify the triangle. It says A triangle with one right angle and two congruent sides. So go ahead and pause the video and make an attempt yourself. Now take a look at example number 2. It says classify the triangle on the house by its angles and by its sides. Well, if I look over here, there are hash marks on these two sides. Well, that tells me something about those two sides. It tells me those two sides are identical. Then if I take a look at this angle right here, the largest of the two angles, then I can, or the three angles, I can say, well, okay, how big is that angle? Is it an acute angle? Is it a right angle? Or is it an obtuse angle? Well, hopefully you're looking at that going, well, I think that's an obtuse angle. You can always take the corner of a paper and lay it along one side. Let's say this one. And you would see that the corner would come out like this, meaning this angle is bigger than 90 degrees. And since that angle is bigger than 90 degrees, that means this is an obtuse triangle that has two equal sides, which means it's also an isosceles triangle. So if I go back here, obtuse triangles have an obtuse angle, and isosceles triangles have two congruent sides. These two would be congruent, just like they are on our house. So we have an obtuse isosceles triangle here on this house. What kind of triangle is this down here on letter B?
Now let's take a look at angles of a triangle. It says here on page 557, the sum of the measures of the angles of a triangle is 180 degrees. That means if we're taking a look at this triangle over here on the right, that if I add the degrees of x plus the degrees of y plus the degrees of z, I should get 180 degrees. And so that's what they're showing you up here where it says algebra in the box. So you can write and solve an equation to find the missing angle of the measure of any triangle. So let's take a look at example number 3. You can see here in example number 3 that there are two angles that are marked. Angle Y is 119 degrees and angle X is 43 degrees. So if I wanted to find the measure of angle Z, I could simply write an equation that says Z, my missing angle, plus 119 degrees plus 43 degrees equals 180 degrees, because those three angles must add up to 180. Before I can start solving this equation, I need to combine my like terms. So I need to add 119 and 143 together. And so what I end up with is Z plus 162 equals 180. Then I can subtract 162 from both sides of the equation to isolate my variable, and I find out that the measure of angle Z is 18 degrees. In this particular problem, I knew that I was looking for the smallest angle and which is opposite of the smallest size side, which means I had to find something that was smaller than 43 degrees. And so my answer makes sense and I can be satisfied with what I got. Now, take a look at letter problem C. Unlike the previous example, we don't have a picture of the triangle. All we have is the measurement of two of the angles, the measurement of angle A and the measurement of angle B. What we are missing is the measurement of angle C. Well, we don't really need the picture in order to do this problem. Go back up here. This equation that we wrote just had the missing angle and the two other angles in it, and they had to equal 180 degrees. I don't need the picture. I just need to know that angle Y was 119 degrees and angle X was 43 degrees in order to write my equation. So you should still be able to do letter C, even though you don't have the picture. Let's move on to example number 4 on page 558. You can see here that there is a flag of the state of Alabama, and it is missing a measure in the bottom right-hand corner. It says X degrees. It says find that missing measurement by writing and solving an equation. Well, just like on the previous problem, we know that those angles have to add up to 180 degrees. So we can say X degrees plus 35 degrees plus 110 degrees has to equal 180 degrees. Like before, I need to combine my like terms first. So I would say X plus 145 is equal to 180 degrees. Then I can isolate my variable by subtracting 145 from both sides of the equation. And then we find out that X equals 35 degrees. And when I write that up here next to the flag, we can see that these two bottom angles were identical, which brings me to another property of triangles. What kind of triangle is formed down here at the bottom? Well, hopefully you can see that there is an obtuse angle here. So we know it is an obtuse triangle. But even more importantly, because it is formed by an X, we also know that this side and this side have to be the same length. They are the same length. So this is not only an obtuse triangle, but it is also isosceles. An isosceles triangle has two same size sides. Well, in addition to having two same size sides, it also has two same side angles. That is true for all isosceles triangles. All isosceles triangles have two identical sides and two identical angles. We're going to talk a little bit more in class about properties of triangles, but we're going to find out that the number of sides and the number of angles that are the same are consistent no matter what kind of triangle it is. So that takes us up to the guided and independent practices on page 558. We will get together and go over those letter problems here in a little bit.